Good evening all. Today we are going to have a discussion on sampling theorem. Myself, Kavipriya, Assistant Professor, EC Department, SNS College of Technology. So what is a sampling theorem? A band limited signal having no spectral components above the frequency FM is the maximum frequency content, can be determined uniquely by values sampled at uniform intervals of sampling time period. Ts is lesser than or equal to 1 by twice of maximum frequency. The Nyquist rate of sampling gives the minimum sampling frequency needed to reconstruct the analog signal from the sampled waveform. So sampling frequency should be greater than or equal to twice the maximum frequency content of the signal. This is the Nyquist criteria. So Nyquist interval is the reciprocal of a Nyquist rate, which is nothing but 1 by Fs. Nyquist interval is the time interval between two adjacent samples. And next is sampling. Formatting an analog signal proceeds in 3 steps. First one is discretization in time, which is known as the name of a sampling. And next one is discretization in amplitude, which is known as a quantization. And last step is the encoding. We'll be assigning the code values to the signals. And next is a definition for sampling. Here in sampling, analog signal is converted to a discrete time signal. So for input is an analog signal and output is a discrete time signal. So discrete in time period. So types of sampling are instantaneous sampling, flat top sampling and natural sampling. And next is the aliasing. If a sampling frequency is lesser than the Nyquist rate, then a type of distortion is referred as a aliasing occurs. So when a sampling frequency is lesser than the Nyquist rate, higher frequency component combines with the lower frequency components and appears as a lower frequency component. So the interference will take place and a distortion will occurs, and this distortion is referred to as a aliasing. So the spectrum of sampled version is called as an aliasing. So this is a diagram which represents a signal. Here if Fs is equal to 2Fm, the signals will touch each other. If Fs is lesser than 2Fm, then the signal will interfere with each other. Low frequency components combine with the high frequency components and it results in an aliasing. If Fs is greater than 2Fm, there will be a proper band gap between the spectrums. So the spectrum will not interfere with each other. It results in no aliasing. To avoid the aliasing, prior to the sampler, low-pass anti-aliasing filter is used. It attenuates the higher frequency components. Filter signal is sampled by selecting a sampling rate slightly greater than the 2Fm. And next is the quantization. So discretization in amplitude is referred to as a quantization. So quantization is a process of sampled discrete time signal into a discrete amplitude signal. So the discrete time signal is converted to a discrete amplitude signal by using a process called as a quantization. So the quantized signal is discrete in both time and amplitude. So the input to the quantizer is a sampled discrete signal, whereas output of the quantizer is a sampled signal which is discretized in both time and amplitude. And next is a quantization error. So quantization error is also called as a quantization noise. So it is a difference between the instantaneous value of message signal and the quantized signal. So Q is equal to V by V minus M. So what is the actual value of the message signal and what is a quantized value? So V is the instantaneous value of a quantized signal and M is a instantaneous value of the message signal. So what is the instantaneous value of message signal and what is the instantaneous value of quantized signal? So by taking a difference between these two, we will be getting a quantization error. Q is equal to V minus M. So types of quantization are uniform quantization and non-uniform quantization. Uniform in turn classified into mid-rate quantizer and mid-rise quantizer and biased. So in case of uniform quantization, the step size between two quantization levels remains constant over the complete amplitude range. Whereas in mid-rate quantizer, Origin lies in the middle of a tread of the staircase. Quantizer output is 0 when input is 0. So that's all about the sampling. So we have seen what is sampling and what is a sampling rate and what is a Nyquist interval and what is a aliasing, and also we have seen what is quantization and what are all the types of quantization, and also we have seen what is a Nyquist interval. When a Nyquist interval is properly followed, there won't be any interference between the signal. So if a Nyquist interval is not properly followed, and it results in a aliasing. Thank you.